Yeah, hello friends. Yeah, congratulations to the next lesson. So last time we worked on element-wise operator. So today we are going to continue. Okay. Yeah. Today we are going to continue on visualization with Matplotlib. Okay. Yes. Last time I asked you guys to go to NumPy documentation. Yes, NumPy documentation. Where you Google NumPy documentation, you arrive for this point. Where you click here. Then from there, or you can still go to just type direct NumPy user guide. NumPy user guide. From there you will read now. See what is NumPy, you read installation, NumPy quick start. You have fundamental usage. Okay. Array creation, so you read all through about NumPy. I read there. Yeah, so that's not our objective of today. I just need to give you a highlight. So you should read about NumPy since we have started using it. Yes. Now, let's type our objective today. We have visualization with Matplotlib. So our objective is visualization with Matplotlib. Are we there? Yeah. Okay. Let's continue. So since we are working on the same platform on the last that we did our last video, so that is why you see this number now is telling us that we are at this number 35, because it's counting in respect to the last lesson. But it doesn't matter. If you open a new file, you start your number from 0, so it doesn't matter. Okay. Now, visualization of NumPy. Now, what is the first thing? We have to create array. Create array. There. So for us to create array, we say x is equals to np.linspace 0 10 100. I will explain later. Okay, so don't bother. Okay, creating an array. Then we create a we give a compute function. Create a compute function. Create compute function. Say okay, y is equals to function y equals to x. Say x square. Is x square. And with the y equals to x square, we have created a function y equals to x square. Yes, you know, we have been working for long with Matplotlib. Is that we wanted to see the diagram. How does the diagram look like for what we have been doing? Are we there? So we wanted to visualize to see the diagram on how it looked like if we plot it. It's the same as we study function in schools, like in mathematics. So we always plot the diagram, and before we plot the diagram, we need to first of all calculate the various functions like derivatives, all those things. But this one, you don't have any problem about calculation. You just need to feed the function, then they can work for you. Okay, so Python will do the work for you, so don't be afraid. That is why I don't want it to be calling in names that you don't know. Okay, say plotting. Say plot. Yeah, we have. Now at this point, if we plot, there's something here that we have to first of all call. Yes, on visualization with Matplotlib, we have to import. You know, we import NumPy, right? We have to see import NumPy now. Then since Matplotlib now is being included of plotting, so we don't need to import also Matplotlib for him to help us to plot also our graph. So we have to import NumPy as np right there. So import Matplotlib dot pyplot as plt Matplotlib dot pyplot as okay. So you have to import this. So now if you are not used to it, you have just copy or you look at a type. Okay, yes, when you import all this, we have to import that. Let's run this code. Okay, they see what the modulus NumPy is an error. Okay, let's look at the error. Okay, you see where that error is coming from. Here, instead of n, we put m. So here, look at it. They say NumPy. Okay, so error should be your friend. Don't be afraid of error. Put n there. When you put n there, you run it back. It's okay. So when you run a line of code, I give you an error. Don't be afraid. Are we there? Yes, don't be afraid. We say plot. We have not completed plot.py. We want to plot x, y, x comma y, comma the label is equals to y equals to x the 2. I will explain it as I said. Don't bother. Comma. We have color type. The color type of our line, blue. Color type, blue. Comma. The line type. The line style. Line style. Let's see. This is the line style. We have this. Check. What is still there? There's nothing. Oh, it's okay. See the string that are determined at line 2. Okay, now I did this for you to understand so many things, because if I'm just doing everything right, you will not know what is happening. Yes, we said this is the function. We say it should plot us what x and y, then you should label what this is the function y equals to x squared. So this is our function y equals to x squared. So this is raised to, we can still remove this one and fit. Are we there? Then make sure now you close the asterisk here. Okay, when you close it this way, it's okay. Are we there? So we forgot to. Then now we move to the color equals to blue. You will see the color is blue. Then the line is a line, straight line. Are we there? It's line. Then let us run it again. Shift and enter. Shift and enter. So you see, wow, congratulations. Are we there? So this is a line of what? Y equals to x squared. Are we together? Okay, if now we change this color, will it change? Let's see. Let's change it to red. This is blue now. Let's change it to red and run our function again. Oh, great. It's showing that our line now turned from blue now it is red. Are we there? Then now let's change this line type. Let's say we use this method. Let's see what will happen. Nothing happened. Are we there? they tell us that we have an error, so you can't do that. So now this is your line. So our line type now will always be at the point. This is like a minus sign, okay? This is the line type. And now the color, the function. So it fall under our level. At this point, we are plotting what x and y plane. Then if you look at now at the portion of our diagram, I want to explain the thing so you to understand well. We state that word from 0 right up to 10. Look at from this point, we say that word create array. This is an array. np.linspace from 0 to 10. Then now we have what 100. It's showing that what 0 to 10. Then 100 now is now for the y-axis. Are we together? So this is 100 from 0 up to 100. Okay. So okay, what if now we happen to change it here to 20? What will happen? Okay, but when you change it to 20, you have to start from that position to start running it back. Run it back, right? Run it all. So when you change to 20, look at it has changed now from 0 now right up to 20. Are we there? So at this point, when it changed now to 20, this other one has changed to 400. So let's move this to 200 and see something. You see, as it changes at this point, it keep on. So long as the issue that so long as this x-axis changes, our y-axis also changes. So for this, how do we manage to have this result? We have said that y equals to x square, right? So now when x is like x is 10, are we there? When x is 10, if it 10 square is 100. So now at this point here, when x is 0, y is 0. But now when x is 20, y is around 4. When x is 60, y is around 8. So when y is 20, x is around 6. When y is 60, x is around 8. When y is 80, so that's why when y now is 100, x is 10. So when now you have 10 here, obviously y is 100. Are we there? So if we fit 20 here, so y will what? Y will change. It will not be 100 again. It will be around 400 as it is. 400. Because why? When you fit 20 at this point, 20 square is 400. So y now turn to 400. Are we together? So if you fit 30 at this point, 30 square, you run your diagram, it become 800. That 30 square become 800. So that is how it is on this. So at this point we have plotted our diagram working on how to the NumPy line space ranging from 0 to 10, 0 to 30, 0, 100. So even if you don't fit this value here, your diagram is going to tell you what your value will look like. Are we there? You know, we can start from the graph, we know the equation, and we can start from the equation, we know how the graph is going to look like. So if we run it, let's say 40, yes, with that it will see give us. So if we fit 40 at this point, so when now x is 40, y will be what? 160. Yes, congratulations, that's great job. So in the next video we are going to continue from there. Okay, yeah, thank you.